Along this lecture, we will find out the radius of a circle. In the drawing, we have a circle. Inside the circle, we have chord dB. That equals to 2 units in itself. This is called AC. That is equals to the square root of 2 units in itself. This is angle DEB. And the side of this angle DEB is 45 degrees. Again, the side of this angle DEB is 45 degrees. And our mission is to find out the radius of this circle. So first of all, we join points A and D together by a straight line. By joining points A and D, we create the peripheral angle BAD. This is peripheral angle BAD. We define the size of this peripheral angle BAD as x over 2. And this peripheral angle BAD is subtended on chord BD. Again, peripheral angle BAD is subtended on chord BD. In the next step, we define the center of this circle, this point, as point O. And we'll join points O and D together by a straight line. We'll also join points O and B together by a straight line. By doing this construction, we actually created here central angle BOD. This is central angle BOD, and this central angle BOD is subtended on the same chord called BD, exactly like this peripheral angle BAD. It is also subtended on the same chord called BD. So now we can implement rule 13 in our drawing. So I repeat quickly on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing, we have a circle. Inside this circle, this is peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Likewise, we have here also central angle AOB. This is central angle AOB, and this central angle AOB is also subtended on the same chord called AB. And according to this rule 4, the size of this central angle AOB must be twice as large as the size of this peripheral angle ACB. Why? Because of the fact that those two angles, they are both subtended on the same chord called AB. And you know that the size of this peripheral angle ACB is theta, and therefore the size of this peripheral angle AOB must be equal to 2 theta. Exactly twice as large as the size of this peripheral angle ACB, that is theta. So the size of the central angle will be always twice as large as the size of the peripheral angle that is subtended on the same chord. So we can actually implement rule 13 in our drawing. In our drawing, those two angles, they are both subtended on the same chord called DB. The size of this peripheral angle DAB is x over 2, and therefore the size of the central angle DOB that is subtended on the same chord called DB must be equal to x over 2 times 2, that is x, according to rule 13. So the size of central angle DOB must be equal to x according to rule 13. In the next step, we define the side of this peripheral angle ADC is y over 2. Again, the size of this peripheral angle ADC is equals to y over 2 degrees. This peripheral angle ADC is subtended on chord AC. So in the next step, we'll join points O and C together by a straight line. And we'll join points O and A together by a straight line. So by doing this construction, we're going to do center angle AOC. This is the center angle AOC, and this center angle AOC is subtended on chord AC. Exactly like this peripheral angle ADC that is subtended on the same chord AC. So those two angles, they are both subtended on the same chord AC. The size of this peripheral angle ADC is y over 2, and therefore the size of this center angle AOC that is subtended on the same chord AC must be equal to y over 2 times 2, that is y, according to rule 13. So the size of the center angle must be twice as large as the size of the peripheral angle that is subtended on the same chord AC. The size of the peripheral angle ADC is y over 2, and therefore the size of this center angle AOC must be equal to y over 2 times 2, that is y. Okay. So in the next step, I'll copy the green triangle AED, this green triangle AED in a new page, and we'll implement rule 4 in this green triangle AED. So actually, this is triangle DEA, this is going through the original drawing. This angle EDA equals to y over 2 degrees in size. This is angle EAD, that is equals to x over 2 degrees in size. And those two angles, they are both defined as the external angles, as the interior angles of this triangle EDA, well, because of the fact that they are located inside triangle EDA. So I want to know those two angles are the interior angles of this triangle EDA. While this is angle BED, and this angle BED is located outside triangle EDA, and therefore it is defined as the external angle of this triangle EDA. So as you know, this angle is an external angle of this triangle EDA. So now we can implement rule 4 in our drawing. So I will present to you the rule 4, and we will implement rule 4 in this triangle EDA. According to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have this triangle. Inside this triangle we have triangles A, B and C. All those triangles are defined as the interior angles of this triangle because they are located inside the triangle, while this is angle E, this is located outside this triangle, and therefore this angle E is defined as the exterior angle of this triangle, triangle E. And according to this rule 4, the size of this exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. This is angle C. This is an interior angle that is adjacent to this angle E. And the two other interior angles that are not adjacent to this angle E are A and B. And the sum of those two interior angles is A plus B, of course. And according to this rule 4, the size of this interior angle E is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is A plus B. Or the size of this angle E is equal to A plus B. So we can implement rule 4 in our drawing. Why? Because in our drawing we have this is triangle EDA, and this angle is angle BED. Angle BED is the exterior angle of this triangle, triangle EDA. And according to rule 4, the size of this interior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle AED, and this angle AED is adjacent to this angle, and the two other interior angles that are not adjacent to this angle BED are those two angles. And the sum of those two angles is x plus 2 plus y, x over 2 plus y over 2. So, we found out that the size of the exterior angle BED according to rule 4 is equal to x plus 2 plus y over 2. So I'll write it down. The size of the exterior angle BED according to rule 4, it is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is x plus 2 plus y over 2. Those are the two interior angles that are not adjacent to this angle BED. So it is x plus 2 plus y over 2. But it is given as the equation that this is angle BED, and the size of this angle BED is 45 degrees. So we substitute angle BED by 45 degrees. So 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2. And finally we get that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x, and y over 2 times 2 is y. So we found out that x plus y equals to 90 degrees. Here we subtract x from this equation, and finally we get that y equals to 90 degrees minus x. So according to equation 1, y equals to 90 degrees minus x. In the next step, I repeat quickly on the law of cosines, and we will implement the law of cosines on both those triangles, triangle BOD and triangle OAC. So So I repeat quickly on the law of cosines. First of all, the law of cosines is true in any triangle. So in any triangle, here we have triangle ABC, that could be any triangle, in any triangle. So this is triangle ABC. The length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle BAC. The size of this angle BAC is theta. So according to the law of cosines, in this triangle ABC, that could be any triangle, the following equation is true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So you can actually implement the law of cosines in any triangle. So we implement the law of cosines on those two triangles. So first of all, we will implement the law of cosines in this triangle, triangle BOD. So I copy this triangle BOD in a new page, and we will implement the law of cosines in this triangle, triangle BOD. But before that, what is the definition of line 7 to OP? Point O is the center of the circle. Point B is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OB is the radius of this circle. We define the radius of this circle as R. Therefore, OB equals to R. Likewise, OD will be also equal to R. OC will be also equal to R. And OA will be also equal to R. So in the next step, I will copy this triangle BOD in a new page, and we will implement the law of cosines in this triangle BOD. Side DB equals to 2 units in its length according to what is given as the question. So actually, this is a triangle DOB, this is according from the original drawing. The next step, we'll implement the law of cosines in this triangle DOB. So according to the law of cosines, this triangle DOB cosine x equals to OD squared. OD is R, therefore OD squared is R squared plus OB squared. OB is also R, therefore OB squared is R squared minus DB squared. DB is 2, therefore DB squared is 4, so it is minus 4 divided by 2 times OD. So it is OD is R, we substitute OD by R times OB. OB is also R, so we substitute OB by R. So in conclusion, we shall find out that according to the law of cosines, in this triangle DOB, cosine x equals to R squared plus R squared minus 4 over 2 times R times R. r square plus r square is 2r square. So in total in the numerator we have 2r square minus 4 divided by 2 times r is 2r square. 2r square over 2r square is 1. We have also here minus 4 over 2r square. So it is actually 1 minus, here we divide both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2r square over 2 is r square. So in conclusion, we should find out that according to equation 1, cosine x equals to 1 minus 2 over r square. In the next step, I'll copy this triangle A or C in the new page, and we will implement the law of cosines in this triangle A or C. Sine AC equals to the square root of 2 units in its length, according to what is given as the question. All C equals to R, and all A also equals to R. So if this is triangle A or C, then the code from the original domain. So in the next step, we will implement the law of cosines in this triangle A or C. So in this triangle A or C, cosine y will be equal to AO square. AO is R, therefore AO square is R square, plus OC square. OC is also R, therefore OC square is R square, minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2. So it is minus 2 divided by 2 times OA, that is R, times OC, that is also R. So in conclusion, we should find out that cosine y, according to equation 2, cosine y equals to R square plus R square is 2R square. So in total, in the numerator of this expression, we have 2R square minus 2 divided by 2 times R is 2R square. So here we have 2r squared over 2r squared is 1. And then also here minus 2 over 2r squared. So it is equals to 1, and here we divide both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So in conclusion, we should find out that according to equation 2, cosine y equals to 1 minus 1 over r squared. This is according to equation 2, but we've already found out that y equals to 19 degrees minus 6. Y equals to 19 degrees minus 6. So I write it down. We already found out that y equals to 90 degrees minus 6. So now we can substitute y in this equation 2 by 90 degrees minus 6. We will do it now, and we get that we have cosine y, and y is 90 degrees minus 6. So cosine 90 degrees minus 6 equals to 1 minus 1 over r squared. So according to equation 2, cosine 90 degrees minus 6 equals to 1 minus 1 over r squared. But we also have the trigonometric identity. It states that sinus x equals to 90 degrees to sinus x equals to cosine 90 degrees minus x. Again, we have the trigonometric identity. It states that sinus x equals to cosine 90 degrees minus x. According to this trigonometric identity, we can substitute cosine 90 degrees minus x by sinus x. Because sinus x equals to cosine 90 degrees minus x. So we do it now, and we get that cosine 90 degrees minus x is sinus x. And it is equals to 1 minus 1 over r squared. 1 minus 1 over r squared. This is according to equation 2. While according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. Again, according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have the values of sinus x and cosine x in terms of r. Now we will use the following trigonometric identity that states that sinus square x plus cosine square x equals to 1. So we can substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, because sinus x equals to 1 minus 1 over r squared. and we substitute cosine x in this trigonometric identity by 1 minus 2 over r squared, because cosine x equals to 1 minus 2 over r squared. So we do it now, and this way we create equation 3. So we know that sinus x, according to equation 1, equals to 1 minus 1 over r squared. If sinus x equals to 1 minus 1 over r squared, it means that sinus square x will be equal to 1 minus 1 over r squared, and then also plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared, and it is equals to 1. So actually, according to equation 3, we found out that 1 minus 1 over r squared plus 1 minus 2 over r squared equals to 1. In the next step, we define t as 1 over r squared, and then t equals to 1 over r squared according to our definition. So now we can substitute 1 over r squared in this equation 3 by t. We do it now, and we get that according to equation 3, we have here 1 minus 1 over r squared. 1 over r squared is t. So we substitute 1 over r squared in this equation by t squared. So in total, this expression equals to 1 minus t squared, and we also plus 1 minus 2 over r squared. Here we multiply this expression by 1. It is allowable to multiply anything by 1, because by multiplying any expression by 1, we will not change the value of the expression. So this expression is minus 2 times 1 over r squared. So it is minus 2 times 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared this expression by t. So this expression in total will be equal to 1 minus 2t squared, and it is equals to 1. So after we substitute 1 over r squared in this equation by t, we found out actually that 1 minus t squared plus 1 minus 2t squared equals to 1. So here we open the brackets on this side of this equation 3, and we get that according to this equation 3, we have 1 minus t squared. 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t, and here plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t is minus 4t, and this is equal to 1. So here we have 1 on both sides of this equation 3, so 1 will get cancelled. After cancelled 1, this side of this equation 3, we have t squared plus 4t squared is 5t squared, and we have also here minus 2t minus 4t is minus 6t, plus 1 equals to 0. So if you found out that 5t squared or 6t plus 1 equals to 0. So actually, this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus C equals to 0. In this general formula, A, B, and C are the coefficients of this quadratic equation, and X is the variable that we are looking for. And we find out the value of X according to the following formula. X equals to minus B plus minus square root of B squared plus 4 times A times C over 2A. In our specific quadratic equation, that is to say, five t squared plus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t. The coefficient A is 5. The coefficient B is minus 6, and finally the coefficient C is 1. The only thing that is left to do is to put the data of our specific quadratic equation, this data, inside the general formula for x, and in this way we find out the value or the values of t, because x equals to t. We do it now, and we get that here x equals to t, so we substitute x by t. So t equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a. A is 5, therefore a is minus 4 times a, so a is 5, and minus 4 times 5 is minus 20, times c. C is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So we found out that t equals to 6 plus minus, inside the root we have 36 minus 20, this is 16, divided by 10. So here we have actually t equals to 6 plus minus, the square root of 16 is 4 over 10. Repeat again, and we found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1. From one side, but from the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We'll do it now. We'll get that 1 over r squared equals to 1. Here we multiply this equation by r squared. And finally we get that r squared equals to 1. Here we take a root out of this equation. And finally we get that the values out that we are looking for is equals to the square root of 1, that is 1. So we found out that the values are of this circle is equals to 1 unit. But it is actually impossible that the values r is equals to 1. Why? Because we know that this is called dB. This is equal to 2 units in itself. And dB is definitely not the diameter of the circle. Again, dB is not the diameter of the circle. So I write it down. This is given us the question. That dB equals to 2 units in itself. And called dB is definitely not the diameter of the circle. Called dB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And the diameter of this circle is 2r. So 2r is the longest chord in the circle, and therefore 2r must be greater than dB that is not the diameter. And dB is 2. Again, the diameter 2r must be greater than dB that is not the diameter. And dB equals to 2. So from this equation, we will derive that 2r is greater than 2. We will divide this inequality by 2 and finally get that r is greater than 1. So actually found out that the radius r of this circle is greater than 1 unit. So if r is greater than 1, r cannot be equal to 1. So this solution is a correct solution. We cancel the solution and we're left only with this second solution for t. The second solution for t is that t equals to 6 minus 4 over 2. It again. The second solution for t is that t equals to 6 minus 4 over 2. Six minus 4 is the second solution for t is that t equals to 6 minus 4 over 10, of course. Again, the second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So t equals to 1/5 for one side, but for the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We will do it now, we will get that 1 over r squared equals to 1/5. Here we cross multiply this equation. And finally we will get that r squared equals to 5. R squared equals to 5. Here we take a root out of this equation, and finally we get that the radius r of the circle, the radius that we are looking for, equals to either the square root of 5 units in itself, or in terms of numbers, it equals to 2.236 units. And again, if we found out that the radius r of this circle equals to either the square root of 5 units in itself, or in terms of numbers, it equals to 2.236 units. So in the next step, I will summarize the lecture. this lecture we found out the radius of this circle. So in the drawing we have inside the circle chord dB that equals to 2 units in its length, chord AC equals to the square root of 2 units in its length, and this is angle DEB. The size of this angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we joined points A and D together by straight line. By joining points A and D, we created peripheral angle DAB. This is peripheral angle DAB, and we define the size of this peripheral angle DAB as x over 2. This is peripheral angle DAB, and this peripheral angle DAB is subtended on chord DB. Again, peripheral angle DAB is subtended on this chord called DB. We define the center of this circle. This point is point O. In the next step, we join points O and D together by straight line, and also join points O and B together by straight line. By doing this construction, we can derive the center angle DOB. This is the center angle DOB, and this center angle DOB is also subtended on the same chord called DB. So those two angles are both subtended on the same chord called DB. So now we can implement rule 13 in our drawing. So according to rule 13, a certain angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and this is called peripheral angle ACB. This is peripheral angle ACB. The peripheral angle ACB, the size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Likewise, we have here center angle AOB. This center angle AOB is also subtended on the same chord called AB. So those two angles are both subtended on the same chord called AB. And whenever you have two angles that they're both of them are subtended on the same chord, then the size of the center angle will be twice as large as the size of this peripheral angle that is subtended on the same chord. The size of this peripheral angle ACB is theta, and the size of this center angle that is subtended on the same chord called AB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. Why? Because in our drawing we have this is peripheral angle ADB that is subtended on chord DB, and this is center angle DOB that is also subtended on the same chord called DB. Therefore, according to rule 13, the size of this center angle DOB must be twice as large as the size of this peripheral angle. The size of this peripheral angle DAB is x over 2. Therefore, the size of this center angle, according to rule 13, must be equal to x over 2 times 2, that is x. Okay. In the next step, we defined the size of this peripheral angle CDA. This angle is y over 2. This is peripheral angle CDA. This peripheral angle CDA is subtended on chord CA. In the next step, we join points O and C together by straight line, and we join points O and A together by straight line. By doing this construction, we created center angle AOC. This is center angle AOC, and this center angle AOC is subtended on the same chord called AC, exactly like this peripheral angle ADC. So those two angles, they are both subtended on the same chord called AC. And therefore, according to rule 13, the size of this center angle must be twice as large as the size of this peripheral angle that is subtended on the same chord called AC. The size of this peripheral angle CDA is y over 2, and therefore the size of this center angle COA that is subtended on the same chord called AC must be equal to y over 2 times 2, that is y, according to rule 13. Okay, so in the next step, I copied the green triangle DEA in a new page, and we implemented rule 4 in this green triangle DEA. So actually, This is the green triangle DEA. This is according to the original drawing. This is again EDA. The size of this again EDA is 1 over 2. The size of this again EAD is x over 2. Okay, so both those two angles are defined as the interior angles of this triangle, triangle EDA, because why? Because they are located inside this triangle EDA. While this is triangle, this is angle BED. It is located outside triangle EDA, and therefore it is defined as the external angle of this triangle, triangle EDA. Okay, so we have two internal angles, and this is one external angle, angle BED. So now we can implement in all four. So I'll repeat quickly on all four. According to all four, the external angle of a triangle is equal to the sum of the two internal angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles A, B and C. All those three angles A, B and C are defined as the internal angles of this triangle ABC because they are located inside the triangle, while this is angle E that is located outside this triangle, and therefore it is defined as an external angle. And according to this rule 4, the size of this external angle E will be equal to the sum of the two internal angles that are not adjacent to it. This is angle C that is definitely adjacent to angle E, and the two other angles that are not adjacent to this angle E are A and B, and the sum of those two angles is A plus B. And according to this rule 4, the size of this angle E is equals to the sum of the two internal angles that are not adjacent to it. That is to say, angle E equals to A plus B. Again, angle E, according to this rule 4, angle E equals to A plus B. It is the sum of the two internal angles that are not adjacent to angle E. So E equals to A plus B. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have this is triangle EDA, and those are the two internal angles x over 2 and y over 2, and this is angle BED that is defined as the external angle of this triangle, triangle DEA. And according to rule 4, the size of this external angle BED will be equal to the sum of the two internal angles that are not adjacent to it. This angle is adjacent to angle BED, and the two other angles that are not adjacent to this angle BED are x over 2 and y over 2. And according to rule 4, the size of this angle BED equals to x over 2 plus y over 2. That is the sum of the two internal angles that are not adjacent to this external angle BED. So according to rule 4, we should find out that the size of this external angle BED is equals to x over 2 plus y over 2. But angle BED equals to 45 degrees, according to what is given as the question. So we can substitute angle BED by 45 degrees. So if we found out that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2, and finally found out that 45 degrees times 2 is 90 degrees, and x over 2 times 2 is x, and y over 2 times 2 is y. So if we found out that 90 degrees equals to x plus y, here we subtracted x from this equation, and finally found out that y equals to 90 degrees minus x. Okay, so in the next step, I presented to you the law of cosines and implemented the law of cosines on both those two triangles, triangle DOB and triangle AOC. So I'll take quickly on the law of cosines. First of all, the law of cosines is true in any triangle. So this is triangle ABC, this could be any triangle. So this triangle ABC, the look of side AB is A, the side AC equals to B units in itself, and side BC equals to C units in itself. And according to the law of cosines, the following equation will be true, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So in the next step, I'll complete triangle AOC in a new page, and implemented the law of cosine. I copied triangle DOB in the new page and implemented the law of cosines in this triangle DOB. So actually, this is triangle DOB that I copied from the original domain. So we know that all the four line segments OB, OC, OD, and OA, they are all the radii of this circle that is equals to R according to our definition. So each of those four line segments OB, OC, and OA and OD is equals to R. It is the radius of the circle. Okay. So again, OD and OB, both the radii of the circle that is equals to R. DB equals to 2 according to what is given in the question, and this is angle X. According to the law of cosines, this triangle DOB, the following equation is true, that cosine X equals to OD squared. OD is R, therefore OD squared is R squared, plus OB squared. OB is R, therefore OB squared is R squared, minus OB squared. OB is 2, therefore OB squared is 2 squared, that is 4. So it is minus 4 divided by 2 times OD, that is R, times OB, that is also R. So in the denominator we have in total 2 times R times R. So in conclusion we found out that according to equation 1, cosine X equals to R squared plus R squared minus 4, or 2 times R. R squared plus R squared is 2R squared. So in total in the denominator we have 2R squared minus 4 divided by 2 times R, that is 2R squared. So we have here 2R squared minus 2R squared is 1, and we also have here minus 4 over 2R squared. Here we divided both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. So in conclusion, we actually found out that according to equation 1, cosine X equals to 1 minus 2 over R squared. In the next step, I copied this triangle AOC in the new page, and we implemented the law of cosines in this triangle AOC. So actually, this is triangle AOC that I copied from the original domain. Again, AO equals to CO equals to R. They are both the radii of the circle that is equals to R, and AC equals to the square root of 2 units in its length, according to what is given in the question. This is again AOC. The size of again AOC is Y. So according to the law of cosines, the following equation will be true, that cosine Y equals to AO squared. AO is R, therefore AO squared is R squared, plus OC squared. OC is R, therefore OC squared is also R squared, minus CA squared. CA is square root of 2, therefore CA squared is square root of 2 squared, that is 2. Divided by 2 times OA, that is R, times OC, that is also R. So it is 2 times R times R. So in conclusion, according to equation 2, we actually found out that cosine Y equals to R squared plus R squared is 2R squared. So in total, the numerator we have 2R squared minus 2 divided by 2 times R, that is 2R squared. Here we have 2R squared over 2R squared is 1, and we have also minus 2 over 2R squared. Here we divided both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2R squared over 2 is R squared. So in conclusion, we found out that according to equation 2, cosine Y equals to 1 minus 1 over R squared. This is according to equation 2. We already found out that Y equals to 90 degrees minus X in the beginning of the lecture. So we can substitute Y in this equation 2 by 90 degrees minus X. We did it, and we actually found out that cosine Y is cosine 90 degrees minus X, and it is equals to 1 minus 1 over R squared. This is according to equation 2. But here we have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, we can substitute cosine 90 degrees minus x by sinus x in equation 2. So in equation 2 we have cosine 90 degrees minus x, therefore we substitute cosine 90 degrees minus x by sinus x. Again, we substitute cosine 90 degrees minus 6 in equation 2 by sin 6. So sin 6 equals to 1 minus 1 over r squared. This is according to equation 2. But according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have the values of sinus x and cosine x in terms of r. Now we also have the trigonometric identity that states that sinus square x plus cosine square x equals to 1. We know that sinus x equals to 1 minus 1 over r squared, and therefore sinus square x will be equal to 1 minus 1 over r squared squared. And we have also plus cosine x. So cosine x equals to 1 minus 2 over r squared, therefore cosine square x will be equal to 1 minus 2 over r squared squared. Okay, and according to this trigonometric identity, it is equals to 1. So this expression is sin square, and this expression is cosine square x, and it is equals to 1. So according to equation 3, we actually found out that 1 minus 1 over r squared squared plus 1 minus 2 over r squared squared equals to 1. So here we define t as 1 over r squared, and then we substitute 1 over r squared in this equation 3 by t. So here we have 1 minus 1 over r squared. 1 over r squared is t. So in total, this expression will be equal to 1 minus t squared. And here we have 1 minus 2 times 1 over r squared. So it is 1 minus 2 times 1 over r squared is t. So in total, this expression will be equal to 1 minus 2t squared. Here, and it is equals to 1. So in conclusion, we should find out that 1 minus t squared plus 1 minus 2t squared equals to 1. Here we open the brackets of this, on this side of this equation 3, and finally found out that 1 minus t squared equals to 1 squared plus t squared minus 2t. And we have plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared plus 2t squared, that is 4t squared, plus 2 times 1 times 2t is minus 4t, and it equals to 1. So here we have 1 on both sides of the equation. So 1 gets cancelled, and after we cancel 1, we have here t squared minus 4t squared is 5t squared, and minus 2t minus 4t is minus 6t plus 1. So in conclusion, we should find out that 5t squared minus 6t plus 1 equals to 0. So this is the quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus 4 to p squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and the coefficient c equals to 1. The only thing that is left to do is to put the data of our specific quadratic equation, this is to say this data inside this general formula for x, and in this way we find out the value of the values of t, because x equals to t. X equals to t, so we substitute x by t, and found out actually that t equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. So it is minus 4 times a, and a is 5. So it is minus 4 times 5, that is minus 20, times c. C is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So we found out that t equals to 6 plus minus 36 minus 26 is 16, so inside the root we have to leave with 16 divided by 10. So t equals to 6 plus minus, the square root of 16 is 4 divided by 10. So here we have two solutions that are possible for t. Again, actually found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10 and 10 over 10 is 1. So according to the first solution for t equals to 1 from one side. But from the other side, according to our definition, t equals to 1 over r squared. So we can solve the t in this equation by 1 over r squared. We did it and found out actually that 1 over r squared equals to 1. We multiplied this equation by r squared and finally found out that r squared equals to 1. Here we took out all of this equation and finally found out that the radius r equals to the square root of 1, that is 1. So actually found out that the radius r of this circle is equals to 1 unit. But it is actually impossible that the radius of this circle r will be equal to 1. Why? Because we know that chord db equals to 2, according to what is given as the question, and chord db is definitely not the diameter of the circle. Again, chord db is not the diameter of the circle. Repeat again, I should have found out that we know that db equals to 2 according to what is given as the question. And from the domains it's very easy to see that chord db is definitely not the diameter of the circle. But we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And the diameter of this circle is 2r. So the diameter of 2r is the longest chord in the circle, and therefore 2r must be greater than db, that is not the diameter. Again, the diameter of 2r must be greater than db, that is not the diameter. And db equals to 2, and from this equation we derive that 2r is greater than 2. We divided this inequality by 2, and finally found out that the radius r of the circle must be greater than 1. The radius r of this circle must be greater than 1. If the radius r must be greater than 1, then the radius cannot be equal to 1. So cancel the solution, and we take into account only the second solution for t. And the second solution for t, here we have two solutions, and the second solution for t will be t equals to 6 minus 4 over 10. Again, the second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t equals to 1/5 from one side. But from the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1/5. Here we cross multiply this equation and finally found out that r squared equals to 5. We took out all of this equation and finally found out that the radius r of this circle, the radius that we are looking for, it is equals to either the square root of 5 units in its length, or in terms of numbers, the radius r of this circle equals to 2.236 units. Again, the radius r of this circle equals to either the square root of 5 units in its length, or in terms of numbers, it is equals to 2.236 units. Okay, thank you very much.